Okay, welcome to this video. We are going to study a type of projectile motion problem involving horizontally launched projectiles. And this is different from what we've done so far because we're looking for the final two-dimensional velocity when it hits the ground. Here's the picture. Our projectile starts right there. It follows this parabolic trajectory. The path is shaped like a parabola. And when we first throw it, it has 1.6 meters per second of velocity. That's the initial velocity, but it's also the x velocity. Because initially, it's only going in the x direction. All of its velocity is x oriented. So after a little time, it still is moving forward at 1.6, and after more time it still is moving forward at the same 1.6, and even at the end here it still is moving forward at 1.6. So what changes over time? Clearly not the x velocity. It stays the same at 1.6. But here's what does change. As this thing falls, the y velocity changes. Initially, there's no arrow to draw whatsoever because at the very start, it's not moving in the y direction and it doesn't have an initial y velocity. But after a little time, right, it speeds up in the y direction. It starts accelerating down because gravity pulls down. And as time passes, it gains more and more y velocity until it's going really fast in the y direction. Let me exaggerate the increase a little bit better. Like that, maybe. So as time passes, the y velocity grows, and right here at the end, this is the moment we want to look at. We know it has some final y velocity. I'll call it final y, like that. And we are going to have to find, and this is the final x velocity, or just the x velocity, because it's not final, it doesn't change. So we are going to have to take that 1.6, add it with whatever the final y velocity is, so that we can find the final 2D velocity. We don't care about theta, because the problem has not asked for theta. This problem only asks for the magnitude of that final velocity. Okay. So we don't need theta, just the final 2D velocity. So I'm going to erase this, and I'm going to leave up that triangle so that we know, so we have our eyes on the prize. This is where we're headed. First, we're going to find VF final, VY final, so that we can find this. Okay, what are the givens in the problem? We know that the thing initially is moving at 1.6. It starts 7 meters up, 7 meters above, so that's the initial vertical position. The initial height is 7 meters up from the ground. And it goes to the ground. So it falls down, it travels down negative the 7 meters. The acceleration due to gravity is negative 9.8. That's the value we use. And what are we looking for? We're looking for that final y velocity so that we can use our geometry to find the final 2D velocity. So we have to choose an equation from all of the equations that we have. We have to choose one that allows us to find VFY. We know those two things. You look through your equations, the ones for y motion. So let's look at those equations and find the equation that has these three things, that, and that. Delta y, ag, vf, v final y. And, oh, not x motion. We don't care about those right now. We're looking at the y motion. V final y. Okay, this is good so far. That's our unknown. Ag, delta y. This is the one. That's the equation you choose to find v final y. So I'm going to write that again up above. V final y velocity squared equals 2ag delta y. Now I'm going to plug in the values negative 9.8. Delta y we saw was negative 7. And you square root both sides to get your answer. What's the value here? Let's see. Mr. Buttons tells me. Boop, beep, beep, boop, 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 beep, beep. And it's 11.71. Wonderful news! Hey! We can erase v final y. You see me erase that? I'm going to erase this, and I'm going to replace it with the value 11.71 meters per second. So what's the final 2D velocity? It's the hypotenuse. It's the hypotenuse of this right triangle. It's a right triangle because the x velocity and the y velocity lie along the x and y axes. And of course, x and y are perpendicular. So it's a right triangle. Geometry comes into play. And how will we find final 2D velocity? We're going to use the Pythagorean theorem. You do that, and you calculate your answer. What do you get? It's going to be pretty close to 11.7. Let's see. 1.6 squared. We want to square root everything. Boop, beep, boop, 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 boop. 11.8 meters per second. So let me move this over. Cannot forget the unit. Oh, it's so important. And that is how you solve.